NASA X-ray technique to discover microbial life on Mars during 2020 mission. Experts will use X-rays and spectroscopy to map organic compounds in rocks. These techniques will allow experts to look for tiny biosignatures of life. The Mars rover will land at an ancient lake, a volcano, or on silica rock deposits. It will take detailed pictures, and collect rocky samples to bring back to Earth. NASA hopes its mission will reveal whether alien life has ever existed on Mars. NASA has announced that it will use a range of techniques including high-tech X-rays to hunt for microbial life during a 2020 mission to Mars. These pioneering techniques will help experts find biosignatures of life, allowing them to make high-resolution maps of postage stamp-sized areas on the red planet. These instruments have previously been used to hunt out the earliest signs of life on Earth, such as deep underground, in hydrothermal vents, and on ocean floor ridges. The mission is not only seeking signs of habitable conditions on Mars in the ancient past, but also searching for signs of past microbial life itself. New methods for searching for the most ancient evidence of life on Earth have led to this leap forward in capabilities for biosignature detection. Experts will use X-ray fluorescence and Raman spectroscopy, which records vibrations in molecules, to map the elements, minerals, and organic compounds in rocks. Past missions have measured the average chemistry over these square centimeter areas, whereas Mars 2020 will make high-resolution chemical maps over a similar area to assess how chemistry changes with shapes or textures observed in the rocks. Dr. Ken Williford, the mission's deputy project scientist, told Mail Online. This approach comes from the methods used to study ancient life on Earth, where we look for interesting chemical features associated with biologically suggestive shapes, for example wrinkly layers, filaments, spheres, etc., observed in ancient rocks, he said. When these methods have been applied on Earth, they have enabled scientists to lower limits of detection or to better understand formally ambiguous observations. Our objective is to collect a diverse set of samples from our landing site with the best potential to preserve records of the evolution of Mars, including the presence of life if it was there, said Dr. Williford, the mission's deputy project scientist, while speaking at the Goldschmidt conference today in Paris. We'll use our onboard instruments to provide the critical field context that future scientists would need to understand the measurements made back on Earth, he said. The automated robot rover will scan the surface of the chosen landing site before taking detailed pictures and collecting rocky samples to bring back to Earth. The rover will have a drill that can collect core samples of the most promising rocks and soils. Mars 2020 takes the next natural step in its direct search for evidence of ancient microbial life, focusing measurements to the microbial scale, and producing high-resolution maps over similarly postage stamp-sized analytical areas, said Dr. Williford. The American Space Agency picked the 3 potential drilling sites during a workshop with planetary scientists in California on February 10. The site with the most votes, the Jezero crater, was once home to an ancient Martian lake. Scientists hope that the extraterrestrial delta, which has once connected to a river but has now dried up, could host the fossilized remains of microbial life. You've got a large river bringing water and sediment into a very large lake, comparable to Lake Tahoe, said Timothy Gouge, a planetary scientist at the University of Texas at Austin, to Nature. Northeast cities, which received the second highest number of votes, once had hot water running underneath its crust. The rocky region was discovered to be a volcano when the robotic spacecraft Mars Global Surveyor stumbled across it in 1996. The last potential excavation site, Columbia Hills, is the most controversial choice. NASA's earlier Martian rover Spirit has previously found silica rocks on the site, which resemble hydrothermal mineral deposits on Earth. but some scientists doubt whether the Mars 2020 rover will be able to assess whether the silica rocks are truly linked to alien life. NASA will make their final decision a year before the mission's launch date in July 2020. The rover will then spend 2 years drilling for rock and soil from the chosen landing site.